So guys, in today's video we are going to deal with structure of functional group. Structure of functional group. So basically in this concept we are going to study what would be the bond angle when you are dealing with your alcohols, your phenols and ethers. Yes, that is what will be the angle between your alkyl or your aryl groups when it is bonded with that of your OH group. Generally when we write your alcohol, we can write it as an ROH. It is a mere representation. But when the concept arises to write it more structurally, so basically they will be saying certain important structure deviations and also more particularly in their bond angle. But before going to that topic, one of the most important thing you have to remember is the two important criteria, so that it would be a better understanding of our later concepts. So first important thing is what? You have to remember that whatever the hybridization of oxygen in your alcohols or in your phenols or in your ethers. I repeat, the hybridization of the oxygen in your alcohols, in your phenols and ethers, they are all sp3 hybridized. That is hybridization of the oxygen in your alcohols, or it could be in your phenols, or even it could be in our ethers. So whatever the oxygen we are looking after over here, they are all sp3 hybridized. And the second most important thing we have to remember is that the magnitude of the electron-electron repulsion. What is that? That is the lone pair repulsion is very much higher when compared to the lone pair bond pair repulsion, which is in turn very much higher than your bond pair repulsion. So these two important points has to be remembered whenever we are dealing with the structure of the functional group in your alcohols, in your phenols and in your ethers. So now when the question arises that what do you mean by this lone pair and a bond pair, let me give you an example. For example, if I am choosing my structure is in this way. Yeah. So of course what we know, whatever the part we have written over here, these are called as what? Lone pair of electrons. Lone pair of electrons. And this represents what? Your bond pair of electrons. So according to this concept, what it is saying, whatever the repulsion, whatever the repulsion which exists between the one lone pair and the another lone pair, it will be called as what? Lone pair repulsion, which is very much higher. So whatever the bonds we have written, of course these are also electrons, but they have been involved in the bond formation. So whatever the repulsion what we are observing over here, it will be called as what? Bond pair repulsion. So now when the question arises between the repulsion of lone pair and a bond pair, it is called as what? Lone pair bond pair repulsion. So when we check out their magnitude of the repulsion, what we are observing, the lone pair repulsion is very much higher when compared to the lone pair and a bond pair repulsion, which is also higher when compared to that of your bond pair repulsion. So this is a very much important concept which can be used for our explanation of your structure or the bond angle of your alcohols, phenols and in your ethers structures. So first and the foremost thing, let us see the structure of our normal alcohols, that is your aliphatic alcohols. So basically I am taking an example over here as my CH3OH, that is your methanol, or in common name it will be called as a methyl alcohol. So of course what we are observing over here, we came to know that whatever the hybridization of your oxygen is there in all the three cases is sp3 hybridized. So the second most important thing I am dealing with now, the hybridization of the carbon. Since it is singly bonded, we know that here what is happening, your carbon is also sp3 hybridized. Yes. And whatever the bond which is present between your C and the OH, alva, I repeat, whatever the bond between your C and the O is present is a sigma bond. So which has been formed by the overlapping of your sp3 hybrid orbital of your oxygen with the sp3 hybrid orbital of your carbon. So what is the major important thing? If I am going to write its structure, of course I can write it in this way: CH3, O and an H. Yes. So basically we came to know that of course in this overall alcohol it is an sp3 hybridized. So whenever an sp3 hybridized comes, what is the geometry which strikes to our mind? Yes, the tetrahedral geometry. And when does this tetrahedral geometry strikes our mind? Of course, we come to know one important thing, that is the bond angle. Alva, what is the bond angle? The angle between two adjacent bonds. So when you're talking about this tetrahedral angle, the bond angle, we know that tetrahedral bond angle is 109 degree 5 minutes. Alva, 109 degree 5 minutes or 109.5 degree. You can write it in that way also. But when I'm talking about practically, when I have measured the bond angle between your C and the OH, that bond angle, this bond angle, basically I have observed, I have getting the bond angle as nearly 108.9 degree. That is, in simple words, I can say that the normal bond angle has been reduced in case of your normal aliphatic alcohols. Question arises, why is it happening so? So in order to understand this, I would like you to focus on my second point. So what has happened, when I am talking about the oxygen in the alcohol, I know that this oxygen is having what? Two lone pair of electrons. And I can give my explanation that why it is decreasing. The main reason is due to the lone pair repulsion. So in alcohols, whatever the oxygen we are seeing, it is having a two lone pair of electrons. And we know that the magnitude of the lone pair repulsion, what is that? It is very much higher when compared to the lone pair bond pair repulsion. Since due to the lone pair repulsion, what happens? The bond angle reduces. Now certain pupils will have a doubt. What is the doubt? So you're saying repulsion. Alva, repulsion andre artha eno? Dura hogbeku. But when you're talking about the repulsion, how can we say that the bond angle is reduced? I repeat my question. It may be a query for you. You can ask me that, sir, when you're saying the bond angle is reduced, you're giving an explanation as what? Due to the lone pair repulsion, the bond angle is reduced. Alva. But we know what? Whenever a repulsion takes place means they should move apart. They should go far away. But how it is coming close? For those pupils, I will once again say that you see the structure properly. What I am talking is the bond angle. I am not talking about the angle between the lone pair of electrons. Are you getting my point? So whatever we are calculating is the bond angle. And as a reason what we are giving is due to the repulsion of these electrons. So if I consider as a normal thing in the same way, let me take a B2 type structure. So let us take that this is having lone pair of electrons, two lone pair of electrons. So what happens? Now the repulsion between this lone pair increases. So what we'll do? Yes, they will come apart. That is, this lone pair will come somewhat over here, this lone pair will come somewhat over here. So now what happens? This is also electron, this is also electron. So when they are moving and coming towards the bond, what happens? This bond try to come together. Are you able to understand? So again, I to lone pair repulsion ಜಾಸ್ತಿ ಇರೋ ಕಾರಣದಿಂದ lone pair electrons ದೂರ ಹೋಗ್ತಾ ಉಂಟು. ದೂರ ಹೋಗಿ ಎಲ್ಲಿಗೆ ಬರ್ತಾ ಉಂಟು? They will try to interact now with the bond pair of electrons. Of course, ಈಗ ಇಲ್ಲೇನಾಗುತ್ತೆ? ವಾಪಸ್ ರಿಪಲ್ಷನ್ ಆಗುತ್ತೆ. ರಿಪಲ್ಷನ್ ಆದಾಗ ಏನಾಗುತ್ತೆ? ಈ ಬಾಂಡ್ ಸ್ವಲ್ಪ ಈ ಕಡೆ ಜರುಗಬಹುದು, ಈ ಬಾಂಡ್ ಸ್ವಲ್ಪ ಈ ಕಡೆ ಜರುಗುತ್ತೆ. ಅವಾಗ ಏನಾಯ್ತು? ಬಾಂಡ್ ಆಂಗಲ್ ಇಸ್ ರೆಡ್ಯೂಸ್ಡ್ ಅಲ್ವಾ? So by that way I am saying, so due to the higher magnitude of your lone pair repulsion, the bond angle is reduced in our alcohols. So that is the reason, instead of having a tetrahedral geometry that is of 109 degree 5 minutes or 109.5 degree, it will be having the bond angle of how much? 108.9 degree in our alcohols. And what is the main reason for that? That is a reduction of your tetrahedral bond angle. The main reason is due to the lone pair repulsion. Able to understand? So don't get confused with the lone pair repulsion and the bond angle. We are not talking about the angle between your lone pairs. Instead, what we are doing, we are talking about the angle between the two adjacent bonds, which is interdependent upon this lone pair repulsion. So one important concept we have to understand what over there. Whatever the reduction in the bond angle we have observed, it is because due to the presence of the lone pair of electrons. So this was in the case of your alcohols. But now if I consider with respect to the phenols, what happens? Yes, I can write my phenols as how? Yeah. In this way, which is my benzene ring, which is being attached to my OH group. So what happens over here? So basically when I'm calculating the bond angle, before that one I have to mention, here what is there? Your oxygen will be an sp3 hybridized carbon atom. Whereas our carbon, what it will be? It will be an sp2 hybridized carbon atom. Let us see how is it. So of course what we are seeing over here, let me give you first my bond angle. So this is having nearly 109 degree. Once again it has been reduced itself, but it is somewhat more when compared to that of your alcohols. What I am saying, I am repeating once again. Of course, tetrahedral angle kinta kammi undu. Tetrahedral angle ಎಷ್ಟು ಇರಬೇಕಿತ್ತು 109.5 degree ಇರಬೇಕು. ಅದಕ್ಕೆ ನಾವು tetrahedral angle ಅಂತೀವಿ. ಆದರೆ phenols ಅಲ್ಲಿ ಏನಾಗಿದೆ, it is having nearly 109 degree. Of course, it has been reduced. But when compared to the aliphatic alcohols, what we are seeing, it is slightly more. Alva. Now the question arises, why is it so? It is also having the lone pair of electrons. It should have also been decreased. But what is happening over here? Whatever the lone pair of electrons which is present on the oxygen in the phenols, they have been involved in the resonance. So when they are involved in the resonance, what happens? Yes. So our carbon atom. So idu illige bandmele enagutte. So now this has come over here, whereas this would be taken by over here. So no. So I'm just writing one structure. So O plus H. So this has been moved over here. Electron density carbon atom ಜಾಸ್ತಿ ಇರುತ್ತೆ ಇಲ್ಲಿ. So like this only it will come when the following resonance structures will be obtained. So what we are observing, whatever the lone pair of electrons were present, they have been involved in the resonance to form a CO double bond. So our reason in the ಏನಾಗುತ್ತೆ ಈಗ? So there will be no interaction between, or there will be no repulsion between a lone pair and lone pair. Instead of that, what will be happening? There will be a lone pair bond pair repulsion. So whenever there will be a lone pair bond pair repulsion, what happens? Of course, compared to the lone pair repulsion, lone pair bond pair repulsion, its magnitude will be lower. But also, what happens? Contraction takes place. Bond angle reduces. But not that much when compared to our normal alcohols. So that is the reason, though there is a reduction in the bond angle, but it is slightly somewhat more when compared to that of your, or you can say slightly somewhat more when compared to that of your normal alcohols. What is the reason? Because whatever the interaction we are seeing, or whatever the repulsion we are seeing, is due to the lone pair bond pair repulsion. Are you able to understand? So by this way we can easily say that why there is a reduction in the bond angle of your phenols. Is that clear? So in the normal alcohols we have seen it has been reduced to nearly 108.9 degree. Whereas in the phenols we are observing it has been reduced to 109 degree. Why is it so? Because here the lone pair of electrons have been involved in your resonance to form an sp2 hybridized carbon atom which will be having a C double bond O character. Now can you say what will be happening in ethers? Well, normally I will be writing my ethers in this way, ROR. Of course, this is the structure. But what has happened over here, remember guys, whatever our R groups are present, what are they? They are the alkyl groups, which means what? We can consider them as a bulkier groups. So of course what happens? So whenever two such bulkier groups are present on their sides, adjacent side, what happens? They will try to repel each other. This will, idu matte idu ಒಟ್ಟಿಗೆ ಬರಕ್ಕೆ try ಮಾಡುತ್ತೆ. ಆದರೆ ಏನಾಗುತ್ತೆ? Because of their bulkiness or heavy molecules, they try to go away. So when they're trying to go away, what happens? Of course, the bond angle increases. So for example, if I talk about my methoxymethane, basically we can see the nomenclature when I'm dealing with the ethers part. Now you just remember, this will be called as what? Methoxymethane. So here you will be having your lone pair of electrons. So what is happening over here? Of course, lone pair repulsion is there, but what is happening? The steric repulsion, that is your bulky groups repulsion, that is called what? Steric repulsion. It will predominate. It will predominate over your lone pair, bond pair repulsions. Are you able to understand? So that is the reason. Due to this steric hindrance, what happens? These groups try to move away from each other. So when they try to move away, what happens? Of course, the bond angles also increases. So that is the reason what we can observe over here. It will be having nearly 111.7 degree. Are you able to understand? So in the normal alcohols, what we saw, due to the lone pair repulsion, the bond angle has been reduced to nearly 108.9 degree. Whereas in the phenols, what we observe, due to the lone pair of electrons which are involved in the resonance, it will be having a lone pair bond pair repulsion. So that is the reason it will be having a slightly lower value compared to that of your tetrahedral angle. But when compared to the ethers, what we are observing, due to the presence of the bulkier groups, what happens? The bulkiness or repulsion increase, that is your steric hindrance, is dominating over your lone pair bond pair repulsion. And in ethers, we are observing as what? The bond angle is greater than that of your tetrahedral angle. Is that clear? Yes. So these were the important 3 points one has to know when we are talking about your alcohols, phenols and ethers. So next we are going to see how to prepare the alcohols from alkenes along with its mechanism. Okay. So now let us see the preparation of alcohols. So basically in this video, I am just going to deal with only one preparation because that preparation is along with its mechanism. So whenever a reaction is with mechanism, it will be easy for your better understanding. Okay. So preparation of alcohols, that is the first important thing I'm going to see is with respect to alkene, from alkene. That is, how can you prepare your alcohols from alkene? Remember guys, if you want to prepare the alcohols from your alkene, it is an acid catalyzed reaction. That means what? If you want to do this reaction, we will be requiring an acid which will be acting as a catalyst. And do remember, it is an addition reaction. What it is? It is an addition reaction. Very much important to note this point. Because we have seen till now, substitution reaction we have seen. Yes, we have seen elimination reaction. Now we are going to see addition reaction. Why I am saying this? Because they are the important classes of reaction in your chemistry. Certain times there may be a chance to ask in your competitive exam by giving certain reaction, and they will ask you, can you please say whether it is an substitution reaction, whether it is an elimination reaction, or whether it is an addition reaction. Of course, you know the difference between the substitution and that of your elimination. Today we'll be seeing with respect to a new type of a reaction which is called as what? Addition reaction. So before that, let us first deal with our reaction, that how can we convert your alkenes to your alcohols using an acid as a catalyst. So basically, when we are treating our alkenes with water in the presence of acid, so what will be happening over here is we are going to get our respective alcohol. We are going to get our respective alcohol. So this is general case. For example, if I am taking my ethene CH2 double bond CH2 in the presence of water, and do remember, never forget to write this acid because it itself is facilitating the reaction to occur. H plus andre presence of acid anta. So ಏನಾಗುತ್ತೆ ಈಗ, of course this H2O will be going to disintegrate as what? H plus and OH minus. So ಏನಾಗುತ್ತೆ ಅವಾಗ ಒಂದು CH2 ಗೆ ಒಂದು OH ಬಂದು ಅಟ್ಯಾಚ್ ಆದ್ರೆ ಇನ್ನೊಂದೇನಾಗಿರುತ್ತೆ, H ನಮ್ಮ CH3 ಗೆ CH2 ಗೆ ಅಟ್ಯಾಚ್ ಆಗುತ್ತೆ. ಅವಾಗ ಏನಾಯ್ತು, H2 ಗೆ ಒಂದು H ಬಂದಾಗ CH3 ಆಗುತ್ತೆ, CH2 ಗೆ ಒಂದು OH ಬಂದಾಗ CH2OH ಆಗುತ್ತೆ. ಇದು ಸಿಂಗಲ್ ಡಬಲ್ ಬಾಂಡ್ ಏನಾಗುತ್ತೆ, ಸಿಂಗಲ್ ಬಾಂಡ್ ಆಗುತ್ತೆ. So now the question arises, sir, why did you say it is an addition reaction? You only observe over here. Nothing has been removed, alwa? Nothing has been removed from our reactant part. Substitution ಅಲ್ಲಿ ಇಲ್ಲ ಹೈಡ್ರೋಜನ್ ಹೋಗ್ತಾ ಇತ್ತು, ಇಲ್ಲ ಯಾವ್ದಾದ್ರು ಒಂದು ಹ್ಯಾಲೋಜನ್ ಆಟಮ್ ಹೋಗ್ತಾ ಉಂಟು. ಆದ್ರೆ ಎಡಿಷನ್ ಆದಾಗ ಏನಾಗ್ತಾ ಉಂಟು, ಯಾವ ತರದ್ದು ಏನು ಚೇಂಜಸ್, ಯಾವ ತರದ್ದು ಏನು ಒಂದು ಆಟಮ್ ಹೊರಗೆ ಹೋಗ್ತಾ ಇಲ್ಲ. ಇನ್ಸ್ಟೆಡ್ ಆಗಿ ಏನಾಗ್ತಾ ಉಂಟು, ಹೊಸದ್ ಯಾವುದೋ ಒಂದು ಆಟಮ್ ಬಂದು ಆಡ್ ಆಗ್ತಾ ಉಂಟು ಅಲ್ವಾ. ಸೊ ದಟ್ ಇಸ್ ದ ರೀಸನ್ ನಾವು ದಿಸ್ ಕ್ಯಾನ್ ಬಿ ಕಾಲ್ಡ್ ಆಸ್ ವಾಟ್, ಅಂಡ್ ನಾರ್ಮಲ್ ಅಡಿಷನ್ ರಿಯಾಕ್ಷನ್. ಆರ್ ಯು ಏಬಲ್ ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ದ ಡಿಫರೆನ್ಸ್? ಸೊ ಅಡಿಷನ್ ರಿಯಾಕ್ಷನ್ ಅಲ್ಲಿ ಏನೋ ಒಂದು ಪರ್ಟಿಕ್ಯುಲರ್ ಆಟಮ್ ಅಥವಾ ಗ್ರೂಪ್ ಆಫ್ ಆಟಮ್ಸ್ ಏನಾಗುತ್ತೆ, ಬಂದು ಆಡ್ ಆಗ್ತಾ ಉಂಟು ಅಲ್ವಾ. So that will be called as what? Addition reaction. Normally in alkenes we'll be seeing addition reaction itself. So it should keep in your mind. ಯಾಕೆ ಏನು ಮೂವ್ ಆಗ್ತಾ ಇಲ್ಲ, ಯಾಕಂದ್ರೆ instead of removing certain atoms, what it is trying to do, it is saturating the bond, utilizing the pi electrons or pi bond ಇಂದ ಏನಾಗ್ತದೆ, ಒಂದು ಹೊಸ ಬಾಂಡ್ ನ ಫಾರ್ಮ್ ಮಾಡ್ಕೊಂತ ಉಂಟು. ಆ ರೀಸನ್ ಇಂದ ಯಾವುದೋ ಒಂದು ಆಟಮ್ ಹೊರಗೆ ಹೋಗ್ತಾ ಇಲ್ಲ. Okay, alkenes they generally undergo addition reaction. Keep that one in your mind. Is that clear? Okay. So now this was okay. I have taken symmetrical alkene, that is your ethene, and I have got what? Ethanol. Alva, ethene in the ethanol ಯಾವ ತರ ಕನ್ವರ್ಟ್ ಮಾಡ್ತೀರಾ ಅಂತ ಕೂಡ ಸರಿ ಕ್ವಶನ್ ಹೇಳ್ಬೋದು. They can ask you, how can you convert ethene to ethanol? So you have to write this reaction, and do remember acid catalyzed is very much important. But now if I am going to give you a reaction in this way, CH3 CH double bond CH2 plus water in the presence of acid. Can you give me the product? Of course, here we can get the two products. But in that I want a major product to be written. Alva? ಏನಾಗಬಹುದು, ಇಲ್ಲ OH. ನಮ್ಗೆ ಏನ್ ಗೊತ್ತಾಯ್ತು, ಈ ಎರಡರ ಮಧ್ಯದಲ್ಲಿ ಯಾವ್ದಾದ್ರು ಒಂದು ಕಾರ್ಬನ್ ಮೇಲೆ ಅಟ್ಯಾಕ್ ಆಗುತ್ತೆ OH. ಇಲ್ಲ ಈ ಕಾರ್ಬನ್ ಮೇಲೆ ಅಟ್ಯಾಕ್ ಆಗ್ಬೇಕು, ಇಲ್ಲ ಅಂದ್ರೆ ಈ ಕಾರ್ಬನ್ ಮೇಲೆ ಅಟ್ಯಾಕ್ ಆಗ್ಬೇಕು. ಯಾಕೆ ಹೇಳಿ, ಈ ಕಾರ್ಬನ್ ಮೇಲೆ ಅಟ್ಯಾಕ್ ಆಗಲ್ಲ, ಯಾಕಂದ್ರೆ ಇದ್ರ ಹತ್ರ 4 ವೇಲೆನ್ಸಿ ಉಂಟು. ನಾವು ಮಾಡ್ತಿರೋದು ಎಡಿಷನ್ ರಿಯಾಕ್ಷನ್, ಎಲ್ಲೂ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಆಗ್ಬಾರ್ದು. ಚಾನ್ಸಸ್ ಇರೋದು ಇವೆರಡರ ಮಧ್ಯದಲ್ಲಿ, ಯಾಕಂದ್ರೆ ಈ ಬಾಂಡ್ ಇಂದ ಯೂಸ್ ಮಾಡ್ಕೊಂಡು ಇಲ್ಲ ಇಲ್ಲಿ ಬಾಂಡ್ ಫಾರ್ಮ್ ಮಾಡಬೇಕು, ಇಲ್ಲ OH ಇಲ್ಲಿ ಫಾರ್ಮ್ ಆಗಬೇಕು. ಈ ತರ ಒಂದು ಅನ್ಸಿಮೆಟ್ರಿಕಲ್ ಆಲ್ಕಿನ್ ಇದ್ದಾಗ ಯಾವ ತರ ನಮ್ಗೆ ಮೇಜರ್ ಪ್ರಾಡಕ್ಟ್ ನಾವು ಡಿಟೆಕ್ಟ್ ಮಾಡಬಹುದು? Yes, by using our Markovnikov's rule. Markovnikov's rule. ಏನ್ ಹೇಳ್ತಾನೆ? So whenever an unsymmetrical molecule, ಅಲ್ವಾ, unsymmetrical molecule ಅಲ್ವಾ, ಯಾಕಿದೆ unsymmetrical molecule? Because you can give us H plus and OH minus. Unsymmetrical bond ಏನಾಗ್ತಾ ಉಂಟು, unsymmetric ಆಗಿ ಬ್ರೇಕ್ ಆಗುತ್ತೆ. So whenever an unsymmetrical molecule adds to an unsymmetrical alkene, I repeat, according to Markovnikov's rule, I am giving the statement. What does he says? Whenever an unsymmetrical molecule is adding to an unsymmetrical alkene. ಯಾಕಿದೆ unsymmetrical? This is symmetrical. ಎರಡು ಆಟಮ್ ಉಂಟು, ಒಂದು ಬಾಂಡ್, ಕರೆಕ್ಟ್ ಆಗಿ ಸಿಮಿಟ್ರಿ ಉಂಟು. ಅದ್ರಲ್ಲಿ ಏನಾಗಿದೆ, 3 ಉಂಟು, ಇಲ್ಲಿ ಒಂದೇ ಇರೋದು. Able to understand? So it is unsymmetrical alkene. So whenever an unsymmetrical molecule is adding to an unsymmetrical alkene, the negative part of an unsymmetrical molecule adds to the carbon atom containing least number of hydrogen atoms. I repeat, the unsymmetrical molecule's negative part adds to the carbon atom containing least, andre less number of our hydrogen atom. ಸೊ ಆ ರೀಸನ್ ಇಂದ ಈ OH ಎಲ್ಲಿಗೆ ಆಡ್ ಆಗಬೇಕು? ಅಫ್ ಕೋರ್ಸ್ ಇವೆರಡನ್ನ ಕಂಪೇರ್ ಮಾಡಿದಾಗ ಈ ಕಾರ್ಬನ್ ಆಟಮಿಗೆ ಲೆಸ್ ಹೈಡ್ರೋಜನ್ ಆಟಮ್ಸ್ ಇರೋದು. ಸೊ ಅವಾಗ ನಮ್ಮ ಪ್ರಾಡಕ್ಟ್ ಏನ್ ಬರುತ್ತೆ, CH3 CH OH ಅಂಡ್ ಡೂ ರಿಮೆಂಬರ್ ಸಿಂಗಲ್ ಬಾಂಡ್. ಯಾಕೆ, ಎಡಿಷನ್ ರಿಯಾಕ್ಷನ್ ಆಗ್ತಾ ಇರೋದು. ಈಗ H ಎಲ್ಲಿಗೆ ಹೋಗುತ್ತೆ, ಅವಾಗ ಗೆ ಬಂದು ಅದೇನಾಗುತ್ತೆ CH3. Sometimes you guys make a mistake. What is the mistake? I'm just trying to write the mistake part. Don't copy and write in the same thing in the exam. Exam ಅಲ್ಲಿ ತರ ಬರಿಬಾಡಿ, ನಿಮಗೆ ಅರ್ಥ ಆಗಲಿ ಅಂತ ಬರೀತೀರ. ಅದೇನ್ ಮಾಡ್ತೀರಾ ನೀವು, ಹರಿ ಬರೀಲಿ, CH3 ಬರೀತೀರಾ, CH ಬರೀತೀರಾ, OH ಬರೀತೀರಾ, ಹೆಂಗೋ ಡಬಲ್ ಬಾಂಡ್ ತೆಗಿತೀರಾ, ಅದೇ CH2 ಅಂತ ಹಂಗೆ ಇಟ್ಬಿಡ್ತೀರಾ. ಇದು ಕರೆಕ್ಟಾ? ಯಾಕೆ ಕರೆಕ್ಟ್ ಅಲ್ಲ? ಅಲ್ವಾ? ಸೊ ಕಾರ್ಬನ್ ಆಟಮಿನ ಸುತ್ತಮುತ್ತ ಎಷ್ಟು ಬಾಂಡ್ ಇರಬೇಕು? 4 ಬಾಂಡ್ ಇದ್ರೆ ಮಾತ್ರ ಅದು ಸ್ಟೇಬಲ್. ಅದು ಇಲ್ಲೆಷ್ಟು ಬಾಂಡ್ ಉಂಟು? ಬರೀ 3 ಬಾಂಡ್. Even though you have written the OH in the correct position, the structure will be wrong. You will be given a 0 marks. So very much uttermost care should be taken. A highly intensive care should be taken whenever you are writing the reaction. Don't do any hurry-burry. Check out each and every reaction atom has been balanced with its valency. Check it out. Reaction balance unta check ಮಾಡಿ. ಆಟಮಿನ ಸುತ್ತಮುತ್ತ ಎಷ್ಟು ಬಾಂಡ್ ಉಂಟು ಅದು ಕರೆಕ್ಟ್ ಉಂಟಾ ಅಂತ ಚೆಕ್ ಮಾಡಿ. ಸೊ ದಟ್ ಈಸ್ ಕಾಲ್ಡ್ ಆಸ್ ವಾಟ್? ಕೆಮಿಸ್ಟ್ರಿ. ಜಸ್ಟ್ ಏನೋ ಬಂತು ಏನೋ ಬರ್ದ್ವಿ ಅನ್ನೋದಲ್ಲ ಕೆಮಿಸ್ಟ್ರಿ. You have to understand. By heart will never give you the fruitful result. I repeat once again. In science, by hearting is just a mere appearance. We can just say for vomiting purpose. You'll not remember. If you are remembering the concept, of course you can try to extract it wherever you may go. Okay? So this is the mistake, common mistake you do. So try to avoid it. Okay? So ಏನಂತ ಗೊತ್ತಾಯ್ತು ಈಗ? ಯಾವಾಗ ನಮ್ಮ ಹತ್ರ ಅನ್ಸಿಮೆಟ್ರಿಕಲ್ ಆಲ್ಕೀನ್ ಇರುತ್ತೋ ಅದು ಎಲ್ಲಾದ್ರೂ ನಮ್ಗೆ ಈಗ ಆಲ್ಕೋಹಾಲ್ ಅದರಿಂದ ಉತ್ಪತ್ತಿ ಮಾಡಬೇಕು ಅಂದ್ರೆ ಇಟ್ ಹ್ಯಾಸ್ ಟು ಫಾಲೋ ವಾಟ್? ಮಾರ್ಕೋನಿಕಾಫ್ಸ್ ರೂಲ್. ವೆರಿ ಮಚ್ ಇಂಪಾರ್ಟೆಂಟ್. ಸರ್ಟನ್ ಟೈಮ್ಸ್ ವಿಲ್ ನಾಟ್ ಗಿವ್ ಯು ಫ್ರಮ್ ಆಲ್ಕೀನ್ಸ್ ಇಂದ ಮಾಡಿ ಡೈರೆಕ್ಟ್ ಆಗಿ ರಿಯಾಕ್ಷನ್ ನ ಕೊಟ್ಟು ಪ್ರೊಡಕ್ಟ್ ಬರೀರಿ ಅಂತ ಹೇಳ್ತಾರೆ. ಮೇಜರ್ ಪ್ರೊಡಕ್ಟ್ ಬರೀರಿ ಅಂತ ಹೇಳ್ತಾರೆ. ಸೊ ಮೇಜರ್ ಅಫ್ಕೋರ್ಸ್ ಅಲ್ಲ ಇಲ್ಲಿ A+B ಬರ್ದೆ ನೀವು ಎರಡು ಬರ್ಕೋಬಹುದಿತ್ತು. ಬರ್ದಾದ್ಮೇಲೆ ಕೂಡ ರಿಮೆಂಬರ್ ಯು ಹ್ಯಾವ್ ಟು ಮೆನ್ಷನ್ ವಿಚ್ ಇಸ್ ಮೇಜರ್ ಅಂಡ್ ವಿಚ್ ಇಸ್ ಮೈನರ್. ಬಟ್ ಇನ್ ಕೇಸ್ ಇಫ್ ದೇ ಹ್ಯಾವ್ ಗಿವನ್ ಓನ್ಲಿ ಒನ್ ಪಾಸಿಬಿಲಿಟಿ, A ಮಾತ್ರ ಬರೀರಿ ಅಂತ ಕೊಟ್ಟಾಗ ಏನ್ ಮಾಡಬೇಕು? ನೀವು ಮೇಜರ್ ನ ಮಾತ್ರ ಇಂಡಿಕೇಟ್ ಮಾಡಬೇಕು. ಸೊ ಇಫ್ ಯು ರೈಟ್ a CH3 CH2 CH2OH, that will be a wrong answer. So you have to write this one as itself as the major product, which will be followed under your Markovnikov's rule. Is that clear, guys? Okay. Now let us see the mechanism part. So whenever a reaction comes, it is my favorite part. ಯಾಕಂದ್ರೆ ಒಂದು ರಿಯಾಕ್ಷನ್ ಗೆ ಒಂದು ಮೆಕ್ಯಾನಿಸಮ್ ಉಂಟು ಅಂದ್ರೆ ಇಟ್ ವಿಲ್ ಬಿ ಲೈಕ್ ಅ ಪ್ರೂಫ್ ಫಾರ್ ಸಮ್ ಡಿರೈವೇಶನ್. ಯಾಕೆ ಅದೇ ರೀತಿ ರಿಯಾಕ್ಷನ್ ಆಯ್ತು ಅಂತ. ಅಂಡ್ ಡೂ ರಿಮೆಂಬರ್, ಐ ವಿಲ್ ಟ್ರೈ ಟು ಹೈಲೈಟ್ ಒನ್ ಇಂಪಾರ್ಟೆಂಟ್ ಪಾಯಿಂಟ್. In mechanism, I repeat, in mechanism, the arrow's representation is very much important. I repeat, in mechanism, arrows representations are very much important. Along with that, the sign, that is which atom will be having a positive sign, where are the electrons, how the electrons are moving. So this all will be indicated in your mechanism. So that for that reason itself we write the mechanism, so that it will be a clear picture of us that how ಒಂದು ಬೇಕರಿಗೆ ಒಂದು ಪ್ರಾಡಕ್ಟ್ ಬರ್ತಾ ಉಂಟು ಅಂದ್ರೆ ಯಾವ ತರ ಮೂವ್ ಆಗ್ತಾ ಉಂಟು ಅಂತ ಹೇಳೋದೇ ನಮ್ಮ ಸ್ಟೆಪ್ ವೈಸ್ ಮೆಕ್ಯಾನಿಸಮ್. ಓಕೆ, ಸೊ ವೆನ್ ಐ ಆಮ್ ಟಾಕಿಂಗ್ ಅಬೌಟ್ ದ ಮೆಕ್ಯಾನಿಸಮ್ ಆಫ್ ಯುವರ್ ಹೈಡ್ರೇಷನ್ ಆಫ್ ಯುವರ್ ಆಲ್ಕೀನ್ಸ್, ಸೊ ಏನ್ ಹೇಳ್ತಿದ್ದೆ ಫಸ್ಟ್ ಸ್ಟೆಪ್. ವಾಟ್ ಇಸ್ ದಿ ಫಸ್ಟ್ ಸ್ಟೆಪ್ ಅಂತ ನೋಡೋಣ. ಸೊ ಫಸ್ಟ್ ಸ್ಟೆಪ್ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ ಇಟ್ ಇಸ್ ಅ ಪ್ರೋಟೋನೇಷನ್ ಆಫ್ ಯುವರ್ ಆಲ್ಕೀನ್. ಪ್ರೋಟೋನೇಷನ್ of alkene to form as what? Carbocation. To form carbocation. ಹೆಂಗಾಗುತ್ತಿದು? by electrophilic attack of yes, hydronium ion. Question arise ಆಗುತ್ತೆ. ಸರ್ ನಾವೆಲ್ಲೂ ಹೈಡ್ರೋನಿಯಂ ಅಯಾನ್ ನ ತಗೊಂಡೇ ಇಲ್ಲಲ್ಲ, ತಗೊಂಡಿರೋದು ಒಂದು ವಾಟರ್, ಇನ್ನೊಂದು ಆಸಿಡ್. ಸೊ ಏನಾಗ್ತಾ ಉಂಟು ಅನ್ನೋದು ಈಗ ನಾವು ನೋಡೋಣ. ಸೊ ವಾಟ್ ಹ್ಯಾಪನ್ಸ್ ಫಸ್ಟ್ ಇನಿಷಿಯಲಿ, ವಾಟ್ ಎವರ್ ದಿ ಸಾಲ್ವೆಂಟ್ ಯು ಹ್ಯಾವ್ ಚೂಸನ್ ಆಸ್ ಅ ವಾಟರ್, ಇಟ್ ಈಸ್ ಗೋಯಿಂಗ್ ಟು ಫಸ್ಟ್ ರಿಯಾಕ್ಟ್ ವಿತ್ ದಟ್ ಆಫ್ ಯೋರ್ ಪ್ರೋಟಾನ್ ಫ್ರಮ್ ಯೋರ್ ಆಸಿಡ್. ಸೊ ಅವಾಗ ಏನ್ ಕೊಡುತ್ತಿದ್ದು? ಎಸ್, ದಿ ಹೈಡ್ರೋನಿಯಂ ಅಯಾನ್, ದಟ್ ಈಸ್ H3O+. Are you able to understand? So this sign is very much important. So once this hydronium ion has been formed, now it will attack our alkenes. So generally I will take my alkenes in this way. C will bond C. So now what it will try to do? So if I am going to write my H3O+ in a proper way, I can write it in this way. H. Yes, it is having one lone pair of electron. The oxygen atom is having the positive center. So now of course this is an unstable molecule. So what it will try to do? Yes. So oxygen, due to its higher electronegativity, it will try to take this bonded electrons towards itself in order to satisfy its positive charge. So see my representation of my arrow mark. Yes, from negative to positive. Negative ಯಾಕೆ? electrons ನ negative ಅಲ್ವಾ? ಆ ರೀಸನ್ ಇಂದ ಯಾವತ್ತೇ ಆರೋ ಮಾರ್ಕ್ ಬರೆಯೋದಾದ್ರು ಹೆಂಗ್ ಬರಿಬೇಕು ನಾವು, ನೆಗೆಟಿವ್ ಕಡೆಯಿಂದ ಪಾಸಿಟಿವ್ ಕಡೆಗೆನೆ ತೋರಿಸ್ಬೇಕು. ಇದು ಲಾಜಿಕ್ ಅಲ್ವಾ? ಎಲ್ಲುಂಟು ಈಗ ನಿಮ್ಮ ಹತ್ರ 4 ಚಾಕ್ಲೇಟ್ ಇದ್ರೆ ಯಾರಿಗಾದ್ರು 2 ಚಾಕ್ಲೇಟ್ ಕೊಡ್ಬೇಕು ಅಂದ್ರೆ ನೀವ್ ಹೆಂಗ್ ಮಾಡ್ತೀರ, ನನ್ನ ಕಡೆಯಿಂದ 2 ಚಾಕ್ಲೇಟ್ ಬೇರೆಯವರಿಗೆ ಹೋಗ್ಬೇಕು. ದ ಸೇಮ್ ವೇ from the higher quantity to the lower quantity it has to move. The same representation. We are not using some new concept, just utilizing our sense. So negative in the positive. Electrons ira kadeinda electrons ildira kadege arrow mark na torsbeku. I repeat once again, you have to always show the arrow mark from where to where, from negative to positive. So again ಆಯ್ತು, ಈ ಬಾಂಡೆಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಆಕ್ಸಿಜನ್ ಕಡೆ ಮೂವ್ ಆಯ್ತು ಅಲ್ವಾ. ಈ ಹೈಡ್ರೋಜನ್ ಈಗ ಹಾಗೆ ಉಳ್ಕೊ ಬಿಡ್ತಲ್ಲ, H+ ಆಗುತ್ತೆ. ಈಗ ಈ H+ ಈಗ ಏನ್ ಮಾಡುತ್ತೆ, ಸುಮ್ನೆ ಇರುತ್ತಾ, ಇರಲ್ಲ. ಏನ್ ಮಾಡುತ್ತೆ, ಇಲ್ಲಿ ಈಗ ಎಲೆಕ್ಟ್ರಾನ್ ಡೆನ್ಸಿಟಿ ಜಾಸ್ತಿ ಉಂಟು ಅಲ್ವಾ, ಬಿಕಾಸ್ ಇಟ್ ಇಸ್ ಹ್ಯಾವಿಂಗ್ 2 ಬಾಂಡ್. ಸೊ ನೌ ದಿಸ್ ವಿಲ್ ಟ್ರೈ ಟು ಕ್ಯಾಪ್ಚರ್ ದಿಸ್ ಹೈಡ್ರೋಜನ್. ಸಿ ಮೈ ಆರೋ ಮಾರ್ಕ್ಸ್, ನೆಗೆಟಿವ್ ಟು ಪಾಸಿಟಿವ್. ಸೊ ಅವಾಗ ಏನಾಗುತ್ತೆ, ಅಫ್ಕೋರ್ಸ್ ದಿಸ್ ವಿಲ್ ಬಿ ಇನ್ ಇಕ್ವಿಲಿಬ್ರಿಯಂ ರಿಯಾಕ್ಷನ್. ಏನಾಯ್ತು, ಈಗ ಈ ಸಿಗೆ 2 ಬಾಂಡ್ ಇತ್ತು ಪ್ರಾಬ್ಲಮ್ ಇಲ್ಲ. ಏನ್ ಮಾಡ್ತಾ, ಅಲಾಂಗ್ ವಿತ್ ದಟ್ ಇಟ್ ಹ್ಯಾಸ್ ಬಿನ್ ಎಕ್ಸ್ಟ್ರಾಕ್ಟಿಂಗ್ ದಿಸ್ ಹೈಡ್ರೋಜನ್. ಸೊ ಇಲ್ಲಿ ಈಗ ಹೈಡ್ರೋಜನ್ ಬಂದು ಕೂರುತ್ತೆ. ಅಲ್ಲಿ ಕೂತ್ಕೊಂಡು ಏನಾಯ್ತು, ಈ ಬಾಂಡ್ ಹೆಂಗ್ ಫಾರ್ಮ್ ಆಯ್ತು, ಬೈ ಯುಟಿಲೈಸಿಂಗ್ ಒನ್ ಆಫ್ ಇಟ್ ಪೈ ಬಾಂಡ್. ಸೊ ಈಗ ಉಳ್ಕೊಂಡಿದ್ದ ಬಾಂಡ್ ಎಷ್ಟು, ಒಂದೇ ಬಾಂಡ್. ಈ ಕಾರ್ಬನಿಗೆ ಇಲ್ಲಿವರೆಗೂ ಏನೂ ಸಿಕ್ಕಿಲ್ಲ. ಸೊ ಡಬಲ್ ಬಾಂಡ್ ಹಾಗೆ ಉಂಟು. ಆದ್ರೆ ಈ ಕಾರ್ಬನ್ ಆಟಮ್ ಮೇಲೆ ಏನ್ ಬರುತ್ತೆ, ವೆರಿ ಮಚ್ ಇಂಪಾರ್ಟೆಂಟ್, ಕಾರ್ಬೋ ಕ್ಯಾಟಯಾನ್ ಫಾರ್ಮ್ ಆಗುತ್ತೆ. Along with that one, you will be obtaining your H2O. ಅಲ್ವಾ, ಹೆಂಗೆ H2O, H3O ಪ್ಲಸ್ ಅಲ್ಲಿ ಬರೀ 1 ಲೋನ್ ಪೇರ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇತ್ತು. ಈ ಬಾಂಡ್ ತಗೊಂಡಾಗ ಒಂದು ಬಾಂಡ್ ಅಂದ್ರೆ 2 ಎಲೆಕ್ಟ್ರಾನ್ಸ್. ಸೊ ಅದನ್ನ ಇಲ್ಲಿ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡಿದೀವಿ. ಒಂದು H ಹೋಗಿದೆ, ಸೊ ಉಳ್ಕೊಂಡಿದೆಷ್ಟು, H2O. ವೆರಿ ಮಚ್ ಇಂಪಾರ್ಟೆಂಟ್ ಇಸ್ ದಿಸ್ ಫಾರ್ಮೇಶನ್ ಆಫ್ ಅವರ್ ಕಾರ್ಬೋಕ್ಯಾಟೈನ್. ಕಾರ್ಬನ್ ಮೇಲೆ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಬರೀಲೇಬೇಕು, ಅಲಾಂಗ್ ವಿತ್ ದಿ ಪ್ರಾಪರ್ ಆರೋ ನೊಟೇಷನ್. ಓಕೆ, step 1 was this. Step 2, let us see. Next ಏನಾಗುತ್ತೆ. So once now your carbocation has been formed, now what happened? Nucleophilic attack takes place. Nucleophilic attack of what? Water. Nucleophilic attack of water on carbocation. Carbocation. That means what? Of course, this is now our carbocation. Yes, C+ like the second, right? So no. So now what happens? Whatever the water you have chosen as a solvent, of course that oxygen is having what? Lone pair of electrons. So again, utilizing this lone pair of electrons, oxygen will go and try to bind with this carbocation. Are you able to see the arrow notation from where it is moving? Yeah, from the oxygen's lone pair of electrons to the positive center of our carbon atom. Alva. So next what will be, this will be also in an equilibrium. So ಯಾವ ತರ ಬರೀಬಹುದು ನಾವೀಗ, C H ಈ ತರ. Next C, of course it is having 2 bonds, but this positive has been balanced with that of your oxygen's water. So just see here, very much important, pay a close observation. O H ನ ಬರ್ದೆ, ಆದ್ರೆ ಒಂದು ಪೇರ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ ನ ಕೊಟ್ಟಿದೆ. ಸೊ ಈ ಆಕ್ಸಿಜನ್ ಮೇಲೆ ಏನಾಗುತ್ತೆ, ಪಾಸಿಟಿವ್ ಸೆಂಟರ್ ಬರುತ್ತೆ. Able to see. So now this oxygen has got what? Positive center. This was your step 2. So when I come with respect to my step 3 now, what might be my step 3? Of course I have a knowledge that in final step I should get my alcohol. So of course I have got in my step 2 as a final product is in this way. H O H and an H, but this oxygen is having what? Positive center. Yes. So now this one along with to form, okay, I should write alva. What will be happening in this step 3? Deprotonation. Deprotonation to form alcohol. So whenever you are writing your steps, first itself you should give the heading to for those steps. Then only you write it. It will be also convenient for you to proceed the reaction. ಎಲ್ಲರೂ ಅಪ್ಪಿತಪ್ಪಿ ಮರ್ತೋದ್ರು ಕೂಡ ಆ ಒಂದು ಕಾನ್ಸೆಪ್ಟ್ ನ ನೋಡ್ಕೊಂಡು ನೀವಾಗೆ ಬರೀಬಹುದು. ಓಕೆ, ಸೊ ಏನಾಗುತ್ತೆ, ಇದು ಸುಮ್ನೆ ಇರುತ್ತಾ, ಇಲ್ಲ, ವಾಪಸ್ ಏನ್ ಮಾಡುತ್ತೆ, ಇನ್ನೊಂದ್ಸರಿ ವಾಟರ್ ಜೊತೆ ಇರುತ್ತಲ್ಲ ಅದ್ರ ಜೊತೆ ಹೋಗಿ ಯಾವ ತರ ರಿಯಾಕ್ಟ್ ಆಗುತ್ತೆ ಅಂತ ನೋಡೋಣ. ಸೊ ಫಸ್ಟ್ ವಾಟ್ ಇಟ್ ವಿಲ್ ಟ್ರೈ ಟು ಡೂ, ಆಫ್ ಕೋರ್ಸ್ ನಾವು ದಿಸ್ ಇಸ್ ಹ್ಯಾವಿಂಗ್ ಪಾಸಿಟಿವ್, ಡ್ಯೂ ಟು ಇಟ್ಸ್ ಹೈಯರ್ ಎಲೆಕ್ಟ್ರೋನೆಗೆಟಿವಿಟಿ ಇದೇನ್ ಮಾಡುತ್ತೆ, ಈ ಬಾಂಡ್ ನ ತನ್ನ ಕಡೆಗೆ ಎಳ್ಕೊಳುತ್ತೆ. ಅರ್ಥ ಆಗ್ತಾ ಉಂಟಾ? ಏನ್ ಮಾಡ್ತು, ಈ ಬಾಂಡ್ ನ ತನ್ನ ಕಡೆಗೆ ಎಳ್ಕೊಂತು. ಹಾಗಾದ್ರೆ ಈ H+ ಸುಮ್ನೆ ಇರುತ್ತಾ? ಅಫ್ ಕೋರ್ಸ್ ನಾಟ್. ಯಾಕೆ ಸುಮ್ನೆ ಇರಲ್ಲ? ಬಿಕಾಸ್ ವಿ ಆರ್ ಯೂಸಿಂಗ್ ಆಸಿಡ್ ಆಸ್ ಅ ಕೆಟಾಲಿಸ್ಟ್. ಸೊ ಇಟ್ ಹ್ಯಾಸ್ ಟು ಬಿ ರಿಗೈನ್ಡ್ ಬ್ಯಾಕ್. ಆಸಿಡ್ ಯಾವ ತರ ಆಕ್ಟ್ ಆಗ್ತಾ ಉಂಟು? ಹೈಡ್ರೋನಿಯಂ ಅಯಾನ್ ತರ ಆಕ್ಟ್ ಆಗ್ತಾ ಉಂಟು. ಸೊ ದಿಸ್ ಇಸ್ ಆಕ್ಟಿಂಗ್ ನಾವ್ ಆಸ್ ಅ ಕೆಟಾಲಿಸ್ಟ್. ಸೊ ನಂಗೆ ಕೆಟಾಲಿಸ್ಟ್ ನ ಮೇಜರ್ ಥಿಂಗ್ ಏನ್ ಗೊತ್ತು? ಒನ್, ಇಟ್ ಡಿಕ್ರೀಸಸ್ ದಿ ಆಕ್ಟಿವೇಶನ್ ಎನರ್ಜಿ. ಸೆಕೆಂಡ್ ಮೋಸ್ಟ್ ಇಂಪಾರ್ಟೆಂಟ್ ಥಿಂಗ್ ಇಸ್ ವಾಟ್? ಇಟ್ ಹ್ಯಾಸ್ ಟು ಬಿ ರಿಗೈನ್ಡ್ ಅಲ್ವಾ ಅಟ್ ದಿ ಎಂಡ್ ಆಫ್ ದಿ ರಿಯಾಕ್ಷನ್. ಸೊ ನಾವು ದಿಸ್ ಆಸ್ ದಿ ಎಂಡ್ ಆಫ್ ದಿ ರಿಯಾಕ್ಷನ್. ಸೊ ಈ ರಿಯಾಕ್ಷನ್ ಈಗ ಬರ್ಬೇಕು ನಂಗೆ. ಸೊ ಅದೇನ್ ಮಾಡುತ್ತೆ? ಬೈ ಯುಟಿಲೈಸಿಂಗ್ ದಿ ಲೋನ್ ಪೇರ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಆನ್ ಯೋರ್ ವಾಟರ್, now once again it will try to take this hydrogen. Able to understand? Only the hydrogen. You see my arrow mark? I'm not showing towards the bond. Instead, I'm showing towards the atom. So this should be the way of your writing. Okay. So now you will be getting as what? Yes, here you will be getting as a H. Of course, here now you will be getting as a OH. Alva. So this will be our alcohol. Plus what you will be getting? H2O ಗೆ ಒಂದು H ಬಂದು add ಆಯ್ತು. Yes, the H3O plus. So our catalyst has been regained back. That is a hydronium ion. So this is the way your reaction is proceeding. So ಯಾವತ್ತೇ ಆಗಲಿ, ಯಾವುದೇ ಒಂದು ರಿಯಾಕ್ಷನ್ ನೀವು ನೋಡ್ತಾ ಇದ್ದೀರಲ್ಲ ಕೆಮಿಸ್ಟ್ರಿಲಿ, ಪ್ರತಿಯೊಂದು ರಿಯಾಕ್ಷನಿಗೂ ಅದರದಾದ ಒಂದು ಮೆಕ್ಯಾನಿಸಮ್ ಇರುತ್ತೆ. ವೆರಿ ಮಚ್ ಇಂಟ್ರೆಸ್ಟಿಂಗ್ ಕಾನ್ಸೆಪ್ಟ್. ಸೊ ವೆನ್ ಯು ಗೋ ಟು ಯುವರ್ ಹೈಯರ್ ಕ್ಲಾಸಸ್, ಆಫ್ ಕೋರ್ಸ್ ಯು ವಿಲ್ ಬಿ ಟೇಕಿಂಗ್ ಯುವರ್ ಕೆಮಿಕಲ್ ಇಂಜಿನಿಯರಿಂಗ್, in all those, you will be seeing that. It will be very surprising to know that how these reactions are taking place. It is like your we will say musical chairs ಅಂತೀವಲ್ಲ ಆ ತರ. ಯಾರು ಎಷ್ಟು ಕ್ವಿಕ್ ಆಗಿರುತ್ತೋ ಅಷ್ಟು ಬೇಗ ಆ ರೀತಿಯ ಪ್ರಾಡಕ್ಟ್ ಸಿಗುತ್ತೆ. ನೀವು ಮ್ಯೂಸಿಕಲ್ ಚೇರ್ ಸುತ್ತ ಹೇಗೆ ಸುತ್ತಾ ಇರ್ತೀರಾ, ಮ್ಯೂಸಿಕ್ ಸ್ಟಾಪ್ ಆದ ಕೂಡ ಏನ್ ಮಾಡ್ತೀರಾ? ಯಾರು ಚೇರ್ ಹತ್ರ ಬಂದು ಪಕ್ಕಂತ ಕೂತ್ ಬಿಡ್ತೀರಾ ಅಲ್ವಾ? ಅದೇ ರೀತಿ ನಮ್ಮ ರಿಯಾಕ್ಷನ್ಸ್ ಕೂಡ. ಇಫ್ ಯು ಫೀಲ್ it is difficult, of course it is difficult. If you feel it is easy, it will be a deadly easy thing. But to make it easy, you have to understand the concept. Don't go for the complex. First you understand the simplest things. Okay. Today we have dealt with a mechanism which is very much easy to understand. So ಯಾವುದೇ ಒಂದು ಮೆಡಿಸಿನ್ ಬರ್ತಾ ಇರಬಹುದು ಅಥವಾ ಯಾವುದೇ ಒಂದು ವ್ಯಾಕ್ಸಿನ್ ಕಂಡುಹಿಡಿತಾ ಇರಬಹುದು, ಅದಕ್ಕೆಲ್ಲ ನಾವು ಫಸ್ಟ್ ಏನ್ ಮಾಡ್ತೀವಿ? ಆ ಒಂದು ಮೆಕ್ಯಾನಿಸಮ್ ನ ನೋಡ್ತಾ ಇದೀವಿ. ಓಕೆ, ನಮಗೆ ಫೈನಲ್ ಪ್ರಾಡಕ್ಟ್ ಸಿಕ್ಬಿಡುತ್ತೆ. ಫೈನಲ್ ಪ್ರಾಡಕ್ಟ್ ಸಿಕ್ಕಿದ್ಮೇಲೆ ನಮ್ಗೆ ಇಂಪಾರ್ಟೆಂಟ್ ಏನಾಯ್ತು ಅಂದ್ರೆ ಹೆಂಗೆ ಈ ಪ್ರಾಡಕ್ಟ್ ಬಂತು ಅನ್ನೋದೇ ನಮ್ಮ ಆರ್ಗ್ಯಾನಿಕ್ ಕೆಮಿಸ್ಟ್ರಿಯ ಒನ್ ಆಫ್ ದಿ ಬೆಸ್ಟ್ ಥಿಂಗ್. ಸೊ ಇಫ್ ಯು ಕ್ರ್ಯಾಕ್ ದಿ ಮೆಕ್ಯಾನಿಸಮ್, ಯು ವಿಲ್ ಬಿ ಕಾಲ್ಡ್ ದಿ ಫಾದರ್ ಆಫ್ ದಿ ಆರ್ಗ್ಯಾನಿಕ್ ಕೆಮಿಸ್ಟ್ರಿ. ಆಲ್ಸೋ, sorry for the girls, you can also be called as mother of the chemistry. Okay, just you have to understand the basic things, that how your nucleophile attacks, how your electrophile attacks, where your positive charge is coming. Even if you are having a mixture of intermediates, that could be your primary carbocation, secondary carbocation, tertiary, you should know the concept that which will be more stable. Higher the stability, the reaction will be faster. Yake? Because ಆ ಒಂದು ಪ್ರಾಡಕ್ಟ್ ನ ಬೇಗ ತಗೋಬಿಡುತ್ತೆ. ರಿಯಾಕ್ಷನ್ ತುಂಬಾ ಜನ ಕೂತಿರ್ಬೋದು. ಸೊ in an interview there will be hundreds of people, but only one judge candidate will be selected who is very much knowledgeable. The same tendency. In the reaction also, that product or that intermediate will be chosen which will be highly stable. So if you are knowing the concept, it will be easy for you to remember this organic reaction. Is that clear? So in today's scene, we have seen as what? The hydration of the alkenes in the preparation of alcohols, and we came to know that whenever we are doing the hydration of the alkene, we require an acid as a catalyst. So if it is a symmetrical alkene, no problem, you can easily write the alcohol final product. But if in case it is an unsymmetrical alkene, it has to follow a Markovnikov's rule. Yes or no? Then we saw its mechanism, which is lying before you. So it includes mainly three important steps. First is your protonation of your alkene to form a carbocation, and how this carbocation is formed by the electrophilic attack of our hydronium ion. Then the next step is your nucleophilic attack of the water on the carbocation. So that is your oxygen will be having the positive charge. Then in step 3, it is deprotonation. You can just see protonation andre attack of a proton. Deprotonation andre removal of a proton. Alva? So you should understand those terms also. So in our next video, we will be going to see certain other preparations, okay, which is also very much important.